Awesome. All right. Well, let's get started then. So, welcome to this blog interview. Nice to meet you.
Yes.
This is our first time, right? I don't think I've had you before.
Yes. Yes.
Okay, cool. Yeah. So in this interview, this is 1 hour mock. By the way, do you know the format?
Not super well.
All
It's
right,
been
I'll go over the format real quick. So this is a 1 hour mock
yeah.
interview. We're gonna just go straight into the problem. We won't do introductions, etc. We don't care about that.
Yeah.
45 minutes solving time. Okay. You
Yep.
signed up for new grad hard, so I'm gonna have you control the time on this one. All right. I will cut you off at 45 minutes, and then we
Okay.
will have 10, 15 minutes at the end for feedback and any discussions. All right.
Yep.
All right. Cool. So by the way, is Python your preferred language?
Yes.
Okay. Okay. Sounds good. All right. Okay. So in this problem, we're going to. Sorry, my mouse is joking. Okay, so in this problem, I want to write me a function that determines if a graph is bipartite or not. Do you know what bipartite means on a graph?
I've heard of it before, but I might need a refresher.
Okay, no problem. Let me go ahead and copy the definition in for you because I am frankly a bit lazy and don't want to really say it. So
Yeah.
I'll voice this over. So what bipartite means? So first of all, read the definition. Why don't you start with that? And if you have more confusions, I'm going to give you an example.
Yep. Sounds good. Bipartite. No self edges. Okay. Graph view. Okay. Cool. 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 No edges to yourself. No parallel edges. I see. I see. Okay. Cool. V is in graph view. Undirected. Cool. May not be connected. May not be. Okay, interesting. So this is the definition of bipartite. It doesn't have to be like necessarily two separate, or I guess that would make sense. Okay,
I
cool.
mean,
So it's just
it
like
has those.
undirected.
I'll give you this one as
Under.
well, just to give you a bit more on that one.
I see. I see. Bipartite. If, no. Two independent sets, A and B, such as. I see. I see. Interesting. Some properties of the graph is such that this is that case. Yeah, let me try to figure out. So do those properties guarantee that definition? I guess I
No,
guess
they
it's,
do not guarantee the definition. So,
I see. So there's some extra properties that make it bipartite essentially.
well, the only property by this definition is this, but
Yeah, yeah.
this is the properties of your input.
Oh, I see. I see. Okay, that makes sense.
Yes.
Cool. So it's like input is like under like standard undirected graph essentially, right?
Yeah,
So
your input's going to be a graph. Yeah.
yeah, yes. In like a adjacency list format, it seems like.
It
Right?
will be an
Cool.
adjacency list, or yeah, it'll be an
Okay, cool.
adjacency list or an edge list. You can choose which one you want.
Okay, perfect. Um, the node in set A and I see. It's like split almost like a function domain type of thing. Okay, cool.
Are we clear on the definition of apartheidness?
Yes, yes. I'm just trying to figure out what kind of like
Okay.
graphs would violate that condition.
Okay. Cool. By the way, there is a drawing tab. You can go to the drawing tab and draw if you want.
Okay, perfect. Oh, interesting. I've never used the drawing tab. Okay, cool.
I mean, you don't have to use it.
Yeah, yeah. Okay, it seems like if there's a node that's, well, yeah, I'll take a look at the drawing pad, but I guess it just might take a little bit of time. So there's a node here, and there's a node here, and a node here. Essentially, it just means that if node A has multiple edges, those edges must all be part of, may never come back to part. All of A's edges, all of A's must not. Okay, let me see if this definition is good enough. All of A's neighbors must not have connections with each other. Let's see if that is sufficient. I think that might not be though. It would be a necessary condition for all of A's neighbors to not have edges with each other. Let's see. There's a one B where that's going to be all of C's edges must also not have edges with each other. Okay, maybe this might be a potential solution. So given any node, all of its neighbors must not have edges with each other. I'm not sure if that's
I noticed you have
sufficient
you have A,
definition.
B, and C. Can you clarify what A, B, and C mean here? Like, are these the names of the nodes?
Yeah, so yes, there's different nodes, and then it's separated by like the two sides, I guess.
Oh, okay, okay, yeah.
Where, yeah,
Yeah, that's right. So this would be a bipartite graph, yeah.
yeah. But I'm just wondering if that solution would be sufficient. So all edges, all neighbors of node A must not have edges between each other. And that would also apply to, for example, like B, where if B is connected to C, then B must not be connected to A, which makes sense.
Yes, that's right. Yeah.
Okay, cool. I feel like this is a sufficient definition. Could be wrong, but if this seems about right, then I can like start thinking about like potential solutions to it.
Okay. Yeah.
Okay, cool. And then the goal of this question is to take an input graph and then return a Boolean of bipartite or not, right?
Yes, correct.
I see. Okay, sounds good. Graph or I'll do JSON. Yes. Okay, let me write out some thoughts first before I go into any implementation. So a very rudimentary solution of a brute force, I guess, would be to compare all neighbors to each other, um, which is not good. So number of neighbors can be n, so this would be n squared, n cubed potentially, if it's like fully connected, or other. Let's see. For every single node, you have all neighbors. Check every single neighbor. I guess it would never get to n cubed because like in a practical setting, but let's just say it's bad for now. To brute force this. And do we have some kind of like time constraint, or are we just trying to get the most optimal?
We'll try to get the most optimal, although I will entertain if you can't think of something better than brute force, but you can just go with that for now.
I see. Let me think. There's another method which is also bad, is splitting all nodes into two groups. This would be two to the power n, two to the power n groups, which is also not good. Okay. Yeah. Okay. Let's see what else. You know. Oh, we have a node B. I've not seen it before. Let me assert it's in one of the halves. It's in one of the sides. Then has not been seen before. Let's see. We have a node that we can identify if it's been seen before. If it has not been seen before, then we should be able to put it into either side. No, we can't. Let's see. Let's see. So future node is one that has been seen before. start from a node and then you do some kind of like BFS from it, where you place the nodes onto the other side when you see that node. Okay. So when you have a graph, when you see a node, so first node is on the left side, and then you place another node. And its edges are all put on the other side, and then all of those must then be put on the other side. All of their edges must be put on the other side, and if it overlaps, then
Can you explain to me what your current train of thought is?
yeah, so right now I'm thinking like we can do some kind of BFS where we start from one single node, and then let's say we assert it's on the left side of the bipartite graph. So, and then by running the BFS, we take all of its neighbors, and all of those neighbors must then be on the right side of the graph. And then we run BFS again on that layer, and because all of the neighbors of that layer must then be on the left side. And then we operate this until we get some kind of like mismatch where putting a certain node on one side where it has a neighbor that is on the same side. So it's, yeah, we would parse through every single neighbor, and then if the neighbor already exists and is on the same side, then it fails, essentially. And that would be, I think,
Okay.
O of n squared, I think. Or, well, let's see. Maximum number of edges is going to be like, yeah, n squared, assuming every single node has like every other node inside. Yeah, I think it would be n squared.
Okay. I think that sounds good enough to approach, yeah.
Okay, perfect. So yeah, let me just explain. So do BFS, start from one, have two sides alternate between sides. Okay. All right. Of node to side. To side. There's going to be left or right. Okay. Cool. So adjacency list. We'll say adjacency list is it's going to be like a hash map of node to list of nodes. Okay. All right. So equals the list. Zero. So I'll just input the first node into it, and then I will process it. So while we have left equals true or false. I'll just have true or false. Equals true. Well, node. I'll process everything in the code. So for node in node Q. Yeah, I should be talking a little more actually. So yeah, so we'll do like for everything in the current node Q, we'll process all the nodes, which is to add all of its neighbors that are not already seen into node Q, and then if the neighbor is already seen, we check if it's the same side essentially, and if it's the same side as the current node, then we break, and then we return false essentially. Okay, so Um, scene nodes. Oopsies. Scene nodes node is equal to side. Let me process all of its neighbors. So for neighbor in adjacency list node. So for every single neighbor, we will check first if it's in. We'll have two conditions. So if neighbor in scene, if it's inside, then we need to make sure it's not in there. So if what is it called? Okay, if scene nodes neighbor is equal to our current side, I'll just do side. Okay, if it's equal to side, then we have 5 part side. This will be our return value, I guess. Equals true. We'll have it as true until we see something false. Equals false. And then we could just return right now, but it would take like a lot of breaking and a lot of if conditions. So I'll just leave that as is for now. Cool. So if it's equal to the same side, then we do this. And then otherwise, so if it's not on scene nodes, then we add the neighbor to the new queue. So so new queue equals to list new queue dots, and then we'll just add the that neighbor into the new queue because we have not seen it yet. Cool. So for every single node, we will assert side, and then afterwards I'll need to side equals side. Okay. And then for every single neighbor that's in this node that we're processing right now, we will see if it's already in the scene nodes, and if it is and it's on the same side, then we assert that it's false. We'll return false. Otherwise, we just add it to our next list to be processed. Okay, cool. And side equals not side. So then, and then at here as well, I'll do node q is equal to new q. Yes, and then everything should be added to scene nodes by default, and then I'll just return by part types. Yeah. What do you think about the overall logic of this?
Is there a reason we're not short-circuiting the return?
Yeah, I was just a little bit too lazy. So I guess we could do it for. So I guess we could do it here. We could also break in. It's just like there are a bunch of places to break. Like if I break it here, then we'll need to break it here as well.
And we could just do return.
Oh, that's what you mean. I'm kind of stupid.
Okay, that's fine. All right, sounds good. Yeah, could you do a time and space analysis, please?
Sure. So let's see. I think upper bound of the time complexity is going to be, so for node, we're only going to process each node once, and then we're going to process each node and its neighbors. So at most it's n squared, but we would have returned if it was n squared, I think.
And what is in here?
Sorry, no. Yeah, sorry, what'd you say?
What's in?
In what? Sorry, what do you mean?
Like what is
and
in?
Oh, sorry, a number of nodes.
Okay.
Number of nodes. Yeah, it's not. Well, it's sorry. It's n times n. Is it based on number of edges? I guess it's somewhat related to the number of edges, but at the upper bound is n squared essentially.
Okay.
Number of nodes, yeah. And then space complexity, I think in practice it probably is lower. I can do a little bit more of like an in-depth analysis of that, but I'll do the space complexity first. And space complexity is going to be every single node. I believe it's just n for space. Space n, yeah.
Okay, and why is it n?
Because the only thing we're storing is like the scene nodes, each node and a Boolean, and the queue is also at most n values. So it's n plus n total.
Okay. Okay, that sounds good. Um, I wanted to, because one thing that you did here, which I want to just quickly discuss, is usually we're talking about the complexity in terms of like both edge like vertices like nodes slash vertices and edges, and I noticed that you use n squared in place of maybe considering the number of edges directly. So if the number of edges was given to you as a variable, how would you reframe the time and space if you would?
Yeah, space would remain the same. Time, let me think, would it be n times n? Let's see. So number of yeah, it would be n times n because for every node, well, for the number of neighbors, essentially for each node we process all of its neighbors. So by nature, it's each node we're processing all of its edges, which is then at maximum 2 times n. So every edge is processed twice essentially if we do both sides, which won't happen actually. Sorry, it's just n. Yeah, it's just number of edges.
So
At
nm
maximum.
is what you're saying.
At
Okay.
maximum.
Okay. All right. Okay. I want to go into a separate problem now, just not related to the first.
Okay.
Okay. In this problem, I would like you to write me a function which takes in a binary tree with unique nodes. So no node value is duplicated. So all values are unique. And I want you to write me a function which takes in that tree, the root of that tree, and an integer k, and return all the values that are k from the root, that are k distance from the root.
Okay. Let me just write it down. Okay, so binary tree, k, all values k dist from, and so is the from roots is just like the actual tree roots essentially, right? So it's like everything on layer k essentially.
Yeah.
Okay, so that's just gonna be like a BFS, and then I return everything on layer k, I guess, and I'm assuming we're passing the roots node, right?
Yes.
Right. There. Okay, sounds good. Okay, there. Okay, this one I should do quickly. I'm assuming in an actual interview I would not be given very much time for this one. Okay, so Q equals this. Okay. Layer equals. And is it 0 indexed or is it 1 indexed for the layers?
The root is
Well,
at
sorry,
distance
k
0.
distance.
The
Yeah,
root
because
is distance
distance.
0.
Yes. Yeah. Cool. So while Q, and at the end layer one. Yep. So I will just fetch, so new Q equals to this for Q, new Q dot and well, if whoops no, if no dot left, and same thing with the right. Q and layer is not equal to k. Yeah, because when the layer appends, if we want layer 1, for example, if we want layer 1, then it will stop after we append all of the nodes. Okay, so cool. Turn path. Is this in scope for me to use? No. Okay. Okay. Let me just check, but I think this is good. Do we want the values of the nodes or just the nodes itself? It's fine.
The nodes itself is fine. That's not a big deal.
Okay. Yeah, I feel like this is okay. Does it look about right?
Okay. I notice your queue is never updated. Is that okay?
Oh, sorry. Yeah, I should have looked a little bit more into it actually. Maybe I'll run through an example.
Don't bother. All right, now the follow-up is that now you're also given a value, v. This value is guaranteed to exist in the tree.
Yep.
You are to return all nodes that are distance k from this value.
Oh, I see, nice, okay. Cool, then. Yeah, so I think I'll do some kind of like recursive. Yeah, I think I'll do some kind of recursive implementation where the nodes below that value, I think are pretty easy to do. So you could increment the counter. So like at the node itself, it's going to be 0. And then you just make it so that the nodes further on are past like 1, let's say. And then when their value is equal to k, then that is added to some, I guess, more so global struct. Or it could be part of the return, but that sounds a little bit complicated. And then for the ones preceding that value, that node, sorry, if one of your children returns 0, it means it had the value. So then you'll return the value plus 1 of your children. And all of the other children will be -1, let's just say. As for invalid, if your return is 0, that means, or some greater or equal to 0 number, then it means that's the distance away from the node that we're looking for. No, sorry, that doesn't work. Because that doesn't account for the ordering. Yeah, if you already processed some other node and then you find the other node, then you wouldn't go back to process. So like the DFS wouldn't really work in that way. Let's see. How else? To construct the entire tree. Of course, if I construct the entire tree and I just like add like a parent value to it, or I construct it as a graph, I guess, then I guess I can construct it as a graph. That would be like a little bit bad for the time and space complexity. But yeah, if I did do a graph, I could just like do a BFS outwards, and that would be pretty easy actually if I just did it that way. Yeah. So let's see. I'll write some comments down. Let me see the actual time and space complexity. So converting into a graph, it would yeah, it would just be like bidirectional graph. So it would be O of n for computing the initial graph, and then space complexity also O of n for that initial graph, and then we just start from the value v and we do a BFS outwards, which is like O of n at max. So O of n total, and then O of n space. Does that work? Do you think that makes sense? The solution?
Yeah, that's fine.
Okay, cool. Okay, so I guess I'll adapt this or make a new function.
Make a new function. You can copy it, but just make a new one.
Yeah. Okay, so um, I'll make it into a graph first. Right, let's see. So if I want to make it into a graph, what do I do? Okay, list goes to hash map. Cool. I'll do a default it. Okay. Okay. Um, add edges. Node. So um, left adjacency list node and dot left, and I'll do the opposite as well. And dot left append node, so it's a bidirectional, and then I'll just change this to right as well. Right, right. Okay, so this way we um, I'll make it recursive as well. So add edges, dot left. So it will add the edges for all of its children as well. Okay, and then this way we just have to call it on the rightmost node. Oh, sorry, on the root node, add edges, roots. Let me make sure if this will create the graph properly. So I'll start at the roots, and then we'll add its children, and then its children to itself, and then we'll process the children nodes. Yeah, okay, that makes sense. Cool. And then after this, after we've gotten this, we'll do a BFS out from the from node with draw. Okay, so um, v node live node dot equals to v node equals to okay, cool. Right, so q equals to Larry equals to 0. Q is equal to a list with the v node as the roots, and then we'll just expand this outwards. So well, Q and layers not equal to okay, so this is gonna be the same thing. I'll just copy the stuff from before. I think it's the same. Oopsies. So Q, we'll have a scene as well. Scene equals a sets, set of nodes. Scene dot add v node. A little bit different. So for node in Q, for neighbor and node. So yeah, if neighbor in scene pass, otherwise we'll process that neighbor, which is we just add it to the new queue. Yeah, okay, so new queue and okay, so add a queue, and then every single node in the queue will add all of its neighbors as long as we haven't seen them before. Sorry. So I'll see that here. Add node. We'll add the node itself after adding it here. So we don't do any replications. Yep. Yes. Okay, I think I'm done implementing, but I can take a look through the logic to see if it makes sense first.
Yeah, that'd be good.
Okay. So to calculate the kth layer as a almost graph version, well, first, so this part, it converts it into a graph, and then we'll run a BFS on that graph. And the BFS part is pretty straightforward, but I can check if the logic is correct. So for converting into a graph, we just iterate through every single node. We add the node, and it's true. Wait, oh shoot, sorry. Local node. Yeah, there it goes. So for every node, we'll add its children. So at most it has left and rights. We'll just create a bidirectional edge, and then we'll process all of its children. So this just creates all of the edges. So it creates the entire graph essentially. And then once we do have that graph, we're able to BFS layer by layer. Similar logic to previously. We just keep track of the layer. We deal with the scene set. And yeah, the final queue we should have should be all the nodes at layer at distance k from the node with value b.
Okay, and then the time and space.
A little bit loud, sorry. So the creating the edges, creating the graph is O of n and O of n for both, and then so for the BFS, it's also going to be O of n for each, yeah, because we're processing each node at most once, and we're also storing each node at most one time in such a queue. So it's O of n for each total.
Okay, that's fine. We have a bit of time left, so I think what we'll do is we'll start a new problem, but probably not finish it. But I want to just get your thoughts on this one.
Sure, sounds good.
All right, so for this problem, you are given a list of binary trees. You're given a list of root nodes, and these are all binary search trees.
Okay.
And you are to merge them, and then return the root of the merged binary search tree.
I see. Okay. Yeah. So let's see. Binary search tree. We can go from the bottom. Okay, we have roots. Yeah, and I'm assuming we want to preserve memory complexity somehow, because like a brute force version would be to just like get all the values and sort it. Actually, well, that would be also bad time complexity.
I mean, what would be the time and space for that if you do it the brute force way?
Yeah, it would be n and n for space and n log n for the time complexity, I believe. Let me just make sure. Yeah, like once you create like once you create like an array of all the values and you sort it with n log n time complexity, then you can just like you can make it into like a simple tree.
Okay.
You can make it in a straight line if you wanted to. But yeah, but obviously it's not ideal. So I'm assuming you want to do it in place actually, like because you already have the nodes. Let's see. If you navigate it to the smallest of the nodes. But you don't have parent nodes. Let's see. Um, parents. I'm curious, actually. Let's see. Have a node. Like, I assume you would do it some way of like you start from the smallest values of each tree, like you go to the bottom and you like somehow rebuild it on top of one of the trees by value. And we're assuming like there are no overlaps in values, right?
There might be. I mean, does it matter?
Oh, interesting. I guess not. No. Let's see.
I mean, okay. So
Hmm.
let's think about this a little bit, right? So
Yeah.
the naive one was you just put all the nodes into a list and you store the list.
Mhm.
What did you say the time complexity there is?
N log n.
And why is that?
Because every single value is being sorted. Oh, it's like you have n values for n nodes total.
Well, it's only true the list is not sorted.
It's only true if the list is not sorted already, you mean?
Yeah, if the list is already sorted, then sorting items should be O of n, right?
Mm. Yes, I see.
Can you produce a sorted list?
Oh, okay. Sort list by iterating through the. Yeah, you would have to start from the lowest values though of each. Then how would you store all this? Because you could have pointers to like the smallest ones, or even if you start at the root nodes. No,
I mean, you
start at the
don't
root
need to
node.
start at the. I mean, obviously you need to start a root node to iterate, but there is an order. But these are all binary search trees, right? Like you're given binary,
Yeah,
like you're given sorted trees.
yeah, but if you do go to like the bottom left, like you wouldn't be able to navigate back up unless you store like a lot of the parent pointers.
Well, but in that case, you wouldn't still need to store in nodes. You would need to store the depth of each tree at worst, right?
Hmm. I see, I see. Interesting. Okay. So you store the depth to be able to retrieve. Um, but it's not just the depth though. Like it also matters like which way it branched. Let's see.
Which type of traversal of a binary search tree gives you the nodes in order? Do you know?
Um, was it no, post order? Yeah, post order. You do like left, left currents, right.
Okay, and then if you take that to a binary search tree that gives you an order, and then what do you do with that? Right. So you do that. So you do the traversal for all the trees at the same time, right? And then this
Mm.
becomes merge k lists, sorted lists.
I see. So you reduce into merge case for list. But what with the memory complexity? Well, like you don't have those k lists yet, though,
No, you would need to
unless you
process them
export
on
them.
like you need to process them on the fly.
So you only process like part of the list, and then
Well,
you do like a merge case
yeah,
for list.
for a traversal, the only amount that's in memory is the height on average, or at worst, right? Like you only traverse to the height. You don't store
Yeah.
everything else. And then for the memory, you're storing like your intermediate data array will have excuse me will have all n nodes anyways.
Yeah. Oh, what do you mean? Sorry, intermediate data, right?
Because I mean, so there's probably two ways to do this. One way is a bit more complex, but I won't talk about that right now. The other way is you produce a sorted list from all of the nodes, from all the trees, by
Okay, and
doing
you
a
just
traversal on all the
merge.
trees, and then
I think.
it takes linear time to convert a sorted list to a binary search tree.
I see. I see. And so that's just like just eating the O of n space complex, like just essentially duplicating the
Yeah,
space.
yeah, yeah.
But
So
I
in
was,
that case, you would eat the O of n space complexity, but you would also only need, but you wouldn't need to sort through all the lists.
yeah, that makes sense. Because merge, what's the complexity for that one again? Like merge and like sort lists. Is that O of n?
I think it's not O of n. It's number of list times n, I believe.
Oh, if you do, especially if you just do like brute force, yeah, yeah, yeah. That
If
makes
you
sense.
do a brute force, yeah. But there's probably better ways to do it. I'm just like there's another
Yeah,
way to do it, which is um, now this one you didn't clarify, but there's another way to do this one, which is based off of merging balance trees, which is a smaller problem than just arbitrary BSTs. Balance trees, they have the guarantee that the height is at most log n, right? That's
I
a
see. Interesting.
like red black or AVL, right? So that makes it a bit more
Yeah, yeah.
optimal. But let's not. But like this is let's move into the discussion. I don't want to spend too much time on this problem. I just want to get your I just want to get a read on it. That's all.
Yeah, that's an interesting problem.
Yeah, I
Yeah,
just
I
want
would
to
need
get a
some
read on
more
it.
time to think about it. Yeah, yeah.
All right. Okay. So let's just go to the main couple of problems we did today. How did you feel about them? From the first, I mean, we start with the first one. You can talk about generally how you did about the problems individually, and also how you felt about the overall process.
Yeah, yeah. I think especially at the start, like my communication was really like bad. I was like staying quiet and like thinking a little bit, not like communicating properly. Um, Solving, I don't know. It was not great. It is what it is, I guess. I think I could have come to the solution a little bit faster, especially for the first question. And then the future, like the other questions were like pretty simple. So like it would have been weird if it took too long. I guess I could have. I do wish I could have implemented a little bit faster. I think a little bit rusty, but
Okay.
um, yeah.
About the okay, about the communication part. Like, why do you think that was bad? Like, is it
Um,
that do you think you could have done better, or you just forgot how to like say the things you wanted to say, or like what was it like specifically about it?
yeah, I think for the first question, like the bipartite part, I should have just like discussed my logic, like thought process, like while I'm thinking, rather than just because I think I went quiet for like a good while, which is
Yeah,
like not good.
yeah,
Yeah, and then I think I noticed that, and then potentially did a little bit better for the future parts, but that was also because like the future parts were a little bit simpler. I didn't have to think too much, so I was kind of able to like describe my thought process, presumably.
I think a lot of it is actually. I mean, that's part of it, right? Like, you can't just like it's almost like as if it's the inverse, where the harder the problem, the more you need to be able to voice your thoughts,
Yeah, yeah,
and it's a vicious cycle because if you don't voice your thoughts, you aren't able to get help from the interviewer, and they
yeah,
aren't able to step in if that's not their if that's not their volition, right? So a really big part of there
yeah,
is I'll tell you I'll encourage you to actually practice problems that you haven't seen before that are difficult, and then figure out, okay, given where I am right now, what would I say, what should I say to optimize my chances of getting help, or by optimizing chances to finish this problem, whatever it is, right?
yeah.
And then that's like a whole skill by itself. So I would encourage you to like spend dedicated time to practice that. Okay. And
That makes sense.
the key thing is that skill is independent of the problem, right? I mean, today we did this problem, but that could be applied to any kind of problem. And
Yeah,
then specifically about the other, the rest of the two problems 2 and 3 that we did today, the thing there is that these are of course much easier problems from an algorithmic standpoint. The thing being tested here, which I think you did actually allude to, is your implementation speed and quality, right? So some of the tests they want to see is they want to see, hey, you know exactly the algorithm to use. Now, can you implement it? So for these two
yeah,
problems, the one I was talking about specifically is the k distance from root and then the k distance from arbitrary node, right? So those two, it's pretty obvious what's going on, and you didn't waste any time at all on the algorithm part. So I think that was well done, right? Now there were a couple things to say, right? I mean, first of all, is there was a little bug going on there, right? For BFS,
yeah,
again, BFS scaffolding, you can't really afford to make a mistake there. So I would
yeah.
definitely recommend you just check up on that. And specifically, what was interesting in your solution here, if I scroll up to it, is you had both the while loop on the queue and the layer but if you notice, you don't actually care about the queue. You only care about the layer. So
Yeah.
this is a situation where like it's not like a bad thing, but the interviewer will think, oh, okay, this person has some intuition on BFS, but they're either memorized the template too hard or they just couldn't figure out what was going on here exactly, right? So I would encourage you to just always think, okay, here's your BFS, what is your exit condition, what is our invariant, etc. Right? So little note there to be had. The bug there also, this is a thing I'll always say is that if you're using a while loop instead of a for loop, right, you're responsible for the exit condition, so you want to make sure that your loop can exit, right? That's all.
Yeah.
All right, and then for the follow up, right, we're talking about the arbitrary node. This one was interesting. I thought. I mean, there's a this is the most common way to do the problem is to convert it to a graph, right? Now I would have liked to have seen a little bit of discussion on the optimization here, right? So specifically, the reason you need to turn to a graph is because you wanted the parent pointers, right?
Yeah.
If you had the parent pointers, you wouldn't need to do this, right? It'd be a graph, right? But here's the thing: is that from the node's perspective, from the V node perspective, everything that is a subtree of the V node, you don't you don't need to convert, right? Because it's already in a navigable manner, right?
Yeah.
So your current solution is going to be quite suboptimal if the V node is close to the root, right? If instead you had a optimization which was like, hey, we only convert the the tree to a graph from the root to the V node, right? That wouldn't give you asymptotic savings, to be clear. I'm not saying that, but I would like to see a bit of discussion there, because that would have given the interviewer a strong signal that you have a very good understanding of why we're using a graph in the first place. So I would say, you don't even need to do it. You just need to point it out. Say, hey, I think there's optimization here. If we were to do this and this, here's why I think it's gonna be better. Here's why I think it may or may not affect the asymptotic complexity. Just call it out. I think is a really big win there, because most of the time, especially in this case, because it doesn't save complexity, they probably would have just told you just to continue on, right? But it's actually very simple to just make the optimization in this case. You could have just if this is V node, you can just not continue, right? So a bit of optimization for you there. I think overall still well done. Like, the problem is still well done. Most of the time, if you are able to perform at this level for your questions, because I would say this problem is a pretty solid middle ground medium difficulty problem. Maybe even a bit on the hard side, if anything. I think you'll be in good shape, right? So I think next step is really communication skills, and then practicing more niche, difficult things. But I think you got the basics down pretty good, and it's just a matter of execution now.
Yeah, that makes sense. Yeah, thanks a lot. Yeah, I guess I could have discussed like the adjacency list. Well, instead of like converting it into a graph, I could have added parent pointers. It would have been a little bit better, because the adjacency list essentially does like parents and the two children essentially. So
which is unnecessary. That's right. Yeah, you could have saved a bit there, but again, that wouldn't have been an asymptotic saving. So it doesn't really matter. But yeah, like those are the kind of things I would have liked to see pointed out, right? And one last thing I'll say before I open it for questions or other things you want to discuss is the time complexity overall was very solid. No concerns there. The only thing I will say is that for graph problems, you shouldn't be using in. You should be using V and E, because most people will be talking about graphs using vertices and edges as separate parameters. Because like you said, yes, the upper bound of E is n squared, right? You have to have two nodes to have an edge, but most of the time, because the number of edges is not correlated with the number of nodes, people usually consider to be a separate parameter. So just keep that in mind, and you should try to use that whenever possible.
Yeah, that makes sense.
All right, anything else you want to discuss on your side?
No, I think that was good. Like, that was pretty good feedback. I'll try to think about those things, and I'll implement those. Yeah, thanks
all right.
a lot for your time.
All right, then take care. Thank you.
Yeah, all right, bye-bye.
All right. Let me send this to them. And then we'll do do all the resume reviews in a second. Lately, haven't been getting a lot of resume reviews, which is really good for me. It's more time for me on Saturday. Let me see. Forms. Not this account. All right, what's a dog doing? Let's take a look. We got one submission. Let's take a look. Take a look. Hope everyone's having a good Saturday, by the way. All right. All right. Well, this guy said trying to break into big tech, SWE or quant, next internship. Okay, so we're aiming pretty high. I love it. International. All right. Let's take a look. By the way, this is the only submission, so if no one else submits, we're ending the stream after this. So you guys better get your shit in, otherwise we're done. All right. Okay. 2027. Okay. AMD, DC GPU. Sub-based regression testing, okay. Developed, okay. I like it. Site infrastructure management, time to percent development modules. Okay. Feels a bit like ops, but okay. It's not a bad thing. Ops is good. Ops is good. Ops just doesn't translate to SWE or quant at all. Resolve recurrent boot race conditions. Some units. Resolved race conditions. Okay, this is good. This is like debugging skills. You were here for 4 months. I mean, it's not bad, but these two are both not really about SWE or quant. Engineered Linux out of band management. So this is good. This is fine. Let's take a look. Anything else you have? Don't know what that is. Data point density issue. Career experience for a lot of this thing. Okay, sure. Improving the query, not quantify, but that's all right. Not quantify. What I would see what you can do there. Redux propagation feature empty axes in SAP. What is this? Propagation feature for empty axes in SAP cloud transmission. I don't know what this means, but it sounds okay. Java Spring Boot, natural language query, reduced. Okay, that's good. I like that. Some CI/CD again. Okay, that's fine. TA, ETL pipeline, Django based search, unsearch. Okay. Ran SQL, CT is on fast backend. Wait, what? Oh, okay. Okay. Pen is a lowercase p. The existing jobs. Okay, this is not bad actually. This is not bad. Serverless platform. Develop features for something as a senior software engineer for various events involving 1,000 plus users. NFC-based event checking system. Okay, cool. That's pretty cool. I like this. This is very nice. Third eye, hacked in north. Voice-activated portable smart camera that assists visually impaired user navigation perception. A little bit of hardware never hurt anybody. That's pretty fun. Trading simulator. Okay. It's a bit redacted for me, but okay. So this is your. Oh, I mean, okay. Let me read your thing again. What did you say? Yeah, this is your only thing related to quant. You have C++ here, right? You had C++ here. This is Python though. What is this? What is this? This is what is it? This is Django. So this is Python. What was this? I don't know what language is. This is like a hackathon language. Just a bunch of random shit. Okay. This is not C++. Almost certainly. Okay. So SWE-wise, I think you're pretty good. You're pretty set. Things look pretty solid. Quant-wise, I would definitely say you want a bit more performance. Low-level stuff, C++ is very, very good. I would definitely expand on that one a little bit more. This is cool. I would say, hey, maybe you can put in a performant back in here. This is a simulator. I don't know what simulator means in this context. This is like a platform, I guess, but I would say I would say prioritize this a bit more if you want to do quant. I think otherwise the resume is a bit I mean, otherwise, sometimes resume is weak. It's that you're just kind of hoping for the best, right? You're not really putting yourself in a winning situation. Everything else is fine though. It's actually a pretty good resume. Just quant's competitive, you know. And since you want it for internship, the bar's a bit lower, so I think it's actually doable for you. You just gotta focus up. All right. What did this guy say? This guy said targeting backend engineering. Oh, this guy wrote a lot. Nice. Backend engineering, data engineering, ML infra, aiming for high performance, high compensation environments, big banks, fintech, data, quant, big tech, ML, backend, advanced industrial autonomous systems. Okay. Backend, data, ML, infra are kind of similar, but not too similar. Is this what is this? Is this a, okay, so they're still a student. Okay. All right, let's take a look. Nice. Look, so lowercase. That's very good. Your spacing's a bit weird over here. Okay, what is this? Re-architected critical from private. Okay. Okay. So first things first, is I'm already saying this resume is probably a bit too embellished for my tastes personally. What I will say, just kind of off the rip, is I personally wouldn't like I this one's, so this point itself is fine at face value, but it's a bit weird, right? Like, for example, I think the work here is pretty good. I don't know if I would frame this as a performance thing. I mean, if this is what happened, this is what happened. But like, going from PySpark to native Java, I would expect a lot more than 40% in performance uplift in terms of latency. Critical is doing a lot of heavy lifting here. I would say the adjective critical is providing no value. If, for example, you're saying, hey, this is a critical thing and we need to do it with no downtime, you could frame it that way. That could be good for framing, ability in your case. If you're just saying this is very critical, we did a thing and the performance is marginally improved, I think this is a bit of a tough sell the way it's currently framed, right? But the point itself is fine, just the framing, right? You gotta think about that. PySpark. Oh no, sorry, this is regular Spark. Okay. Dashboard, schedule, DevOps, version control. Okay. Power BI. Don't care. This is a R&D intern. This one you're here for? Oh, you just started. You just started. These are all past tense. I would clarify that, right? So make these. If you're applying right now, change this to be future or like present tense. If you're not gonna apply right now, you're gonna apply after August, then past tense is fine. Okay, so you're also here for 8 months. Okay, wait, you're here for 8 months. Why is there only 2 points? What's going on? Okay. Okay. So all right, look. So this thing, um, this is one of those kind of things where, for example, I don't really know much about Unity XR simulations and MetaQuest. Like, I don't know if this is like you use the framework and it just has this performance. In which case, this is not relevant, right? Like, you just used a thing and the byproduct is this. Versus if you use a thing, the performance is fucking dog shit, and then you did something else on top of it, which then did something very very cool, right? Then these things, right, and this data pipeline, then it matters. But if it's a case where like you just did a thing out of the box and then this is what you got, that's sort of like whatever, right? Similar to this thing, right? So you did this thing, 15 hertz real time performance. I'll be honest with you, I have no idea if that's good or bad. When I think about it, on my side, 15 times per second is like really slow. Now I don't know what ROS2 is, so maybe that's very good for ROS2. But again, right, if you're not applying to whatever, like this is like robotics, the hell's ROS2? ROS2. yeah, robot stuff, right? If you're not going to like robotics, where people don't know what the hell an ROS2 is, they're gonna like it doesn't, you know what I mean? Like it's a bit weird, is all I'm saying. It's a bit weird. So you're going for not robotics, so I would maybe reframe this to be a bit more relevant. Because look, you spent 8 months here. This is your only other experience. You know, you want to put some more stuff here probably. All right, projects. Immediately, let me take a look what's going on here. Okay. So the first thing I'm also noticing is there a backend on this resume? Is there backend? Was this one with Spring? No, the other one was Spring. Do you have backend? Okay, I'm not seeing backend. So let's take a look. Maybe the projects have backend, right? No. Okay, does this have backend? Spring Boot. Okay, we have backend here. We have a backend. We have a backend. What's Gunicorn? G Unicorn? Okay. What I'm saying, okay, so this resume is decent for backend infra. I think you're definitely there for infra. Maybe not ML infra. I'm not sure if that's probably more competitive, right? But backend infra, I'm seeing some stuff here that's pretty good. I think if you continue at this trajectory, you would have a pretty good shot at maybe big tech. Banks, I think there's a chance. Banks, you could probably go for this low resume. I mean, right now it's not quite there yet, but like Capital One, Morgan, you're gonna get there eventually. Quant, probably need a bit more work. Specifically on a bit more work on performance and like low level work, right? I don't see any low level here. I mean, I know you put C as your third language, but I don't really see C like at all. This is right. Like what is this? I don't even know what this is, to be honest. C# here. This, I don't know what this is. This is a C# kind of thing, right? I don't see anything low level, so that's just out of the question. I think you can get there though. I don't have any doubts about that. You can get there, but right now it's a bit far off. But yeah, big tech, I think you'll get there eventually. You just keep working at it. Also good to just start stacking full-time experience when you can. I mean, I know you're not quite there yet in terms of graduation date, right? But once you get into full-time, your experience matters a lot more. As an intern, everyone kind of knows, oh, you're an intern. This is just random ass bullshit, you know. Unless you're doing something reputable, then it's just about who can say more adjectives, who can say more numbers. Everyone knows that. It doesn't really matter. Resumes targeting back-end internships. Okay. Oh, Saskatchewan mentioned. Okay. All right. AI-powered ed tech platform. Backend architecture, learning platform, sending students, RESTful APIs, blah blah. Firestore. Okay. See, this is a good use of Firestore. Firestore is really good for like 70 students. Like this is the right thing to use Firestore for. Row. Okay. It's ended a little while ago. That's chill. Program development intern. Mentor preparation time. Develop scheduling, reporting, automation tools. Okay, this is chill. This is chill. I mean, this is definitely a bit. This sounds definitely a bit less technical, but I think it's okay. I would maybe spend a bit more time and elaborate a bit more on like what specific tools did you build. Like, I mean, I think it's good to see you build tools that help people, but if you go a bit more detail here, this is probably worth it. Unless they're really not relevant, then you can make the call, right? It's just that, you know, like this, you have some experience, you have a lot of projects. I would try to bump up the experience a bit more if you can. Projects, autonomous RVR navigation agent. Okay. Right, so again, so one thing I'll also say is that because your experience was a bit far ago now, right? So this is already 8 months ago. I would start putting dates under projects so people know what you're actively working on. This is going to be quite important, I think. And also, if you have demos, I see you don't have any links, any demos, any videos people can GitHubs people can look at. I think that would be good to put in as well. Okay, Timeless Waste Agent. Don't write unit tests for this. This doesn't matter. Okay, cross-language real-time chat system. Okay. with low latency messaging. Okay. Integrated some stuff. These two can be put in the same point, I think. There's none, you can save some room there. Okay, so this one, see, this is the one where it'll really benefit from having a demo or something going on, because the thing is that this could really be something that's super, super basic, or it could have a bit of flair on it. So I think this is something which, right now, I mean, I give you the benefit of the doubt, but this is just a pretty basic stuff I'm reading, right? But I can maybe imagine this is more complex. I think this is very commonly, this is the thing I see with students is, you write a lot of stuff, but I don't really know what it is, right? This sounds like a school project kind of thing. This is cool. All right. I mean, you already have systems over here. In that case, I wouldn't put systems over here. Would you have it? Yeah. So I wouldn't put both there. All right, got one more. Let's take a look. All right, so this guy said, looking for international software engineering roles. Wouldn't mind hardware. Has some experience in the two fields: software from personal learning and hardware a bit from coursework and personal learning. Okay. International. All right, sounds good. See that? Look, guys. Even these guys from outside of here have figured out how to use a template. All right. Okay. Fourth of 100 teams. Okay, these are both pretty good. I like that. That's good. Okay, definitely a bit of a student stuff over here. No one uses Verilog in the in their personal product, but I like to see that. Okay, electrical engineering. Okay, FPGA, Verilog. Yeah, that makes sense. Something okay. Collaborated on debugging. I'm just in the oscilloscopes and electrical analyzers. Okay. IoT based. Okay, so all right, this one is interesting. I would say so. This one sounds like there's like a group or like a team component here. Just be very sure that if you're saying that this is the one that's collaborated on, it's implying that the other two you did yourself, right? So that's not the case. Then make sure you make that very clear in this. For example, this is a school project or something. Then it seems like the first point is the bulk of the work, the bulk of the project. So if this is not, if this thing you did solo, make sure to point that out. Okay. Grain-based condition monitor system. Okay. Okay. Integrated machine learning models to predict future grain storage conditions. Does feature empower user with actionable insights? Interesting integration. Okay. So the first thing I'll say is that the positioning of this is very different than the rest. I think it's okay to put as it is, but just be aware that a lot of this is going to be about again, I'm giving you the North American context here. This is what we look for when we hire. Is this could definitely be cut down a bit. For example, we don't need to know you use Firebase and Blink. This is not relevant to your contribution, right? And also, I would just say a little bit about yourself here in terms of the machine learning model. For example, you were talking about the integration of the machine learning model. I think that's good. Now, if you worked on the model itself, that would be good to bring up as a separate point, right? But I mean, here I'm taking your word for it. This is just integration, so I think what you have here to explain that is fine. Okay. Okay. I mean, I would say in this case, if it's a competitive environment, I would like to see some stats, right? So you have to think to do some stuff. What's the accuracy? What's the error rate? Right? That kind of thing. Smart doorbell. Right, so this is definitely a case where like there's 10 people, that's a lot of people. first point I think is fine to just go over overall what the project is about, but I mean we definitely want to see what you did, right? So you contributed to the integration, implementation, etc. But like, what did you do, right? Like this is the kind of thing where it's very iffy on your specific contribution. So from this, you can't really see what what you did, right? So I think this is okay to put as like a, yeah, we did this thing. This is something we have some knowledge on, but in terms of resume value, you got to be very clear about that, right? Like it's going to be hit or miss depending on the person. Okay. Okay, that's all the resumes for today. So I'm going to end the stream here.